Assalamu alaikum, grade 6. Welcome again to the physics session. Today, inshallah, we're gonna start lesson number 5 in chapter number 2, and actually, this is the end of this chapter. The title of today that's talking about the free fall and the circular motion. What's the meaning of free fall and the circular motion? Any object that's falling down with the only gravity force that's called free fall. And the circular motion when the motion happen in the circle. And that's what we're talking about today. In the beginning, founding yourself. The GPS. Each one of you that's knowing what's the meaning of GPS. GPS, that's global positioning system. That's like constellations in the sky that's made up of satellites in that orbit 10,000s and 60 miles above the earth. So you can check a look. This is table that's talking about the satellites GPS to founding location in our earth surface between the different periods, beginning with the 1978 and the number of GPS above the earth in 2007. In the beginning, the GPS that make it possible for the people with ground reserve to pinpoint their geographic location. So the GPS global positioning system that satellites above the earth in this specific orbit that moving around the earth in the specific orbit to sending messages and signals to make the GPS or founding location in the earth surface. How this is GPS moving around the earth, that's due to the circular motion, and today we're talking about this. In the beginning, we can watch in this video that make imagination about how this is probe or space probe in the same orbit around the earth, and how this is man that jumping from the space to free fall. Watch and absorb what's happening. So, this is video. I want to ask you a question. What's the reason for raising the speed and velocity for this is man, acceleration for this is man from or the starting jumping in the earth or atmosphere of earth, and how the space probe that's still in the same place around the earth in the same orbit. That's what we're talking about today in the free fall and circular motion. And I want you to focus with me. Today, our points number 1, what is free fall? Free fall, any object that fall down with the gravity force, only acting with the gravity force, I called it free fall. So when only the force acting on an object is gravity, only force gravity, that object is cited to in fall or free fall, and which causes an object to accelerate. When the object starts to fall down with the gravity, start raising the acceleration for this object. What's the meaning of acceleration or accelerate? That's meaning changing the speed by changing the distance, or here the height. Okay, the near of the surface Earth, the acceleration due to the gravity is that important number in physics. That acceleration of gravity in Earth surface, that's 9.8 meter per second squared, and this is mean that for every second an object is falling and its velocity increasing by 9.8 meter per second. I want you to focus here deeply. In the near and Earth surface, that has important number that's describing the acceleration due to the gravity, meaning the raising of velocity of an object when flow down due to the gravity, and that's constant in the Earth, that's 9.8 meter per second squared, and that's meaning every second the object increasing the velocity by 9.8 meters per second. Excellent. I hope you understand this. And all objects in free fall accelerate at the same rate, no matter what their masses are. You can watch this video describing two objects but different in masses that's falling down in the same rate. Why? Because the acceleration for all objects in the free fall, that's the same rate. So the acceleration with the gravity is constant in Earth, 9.8 meters per second. Excellent. Now we can going to the next step in our lesson today, that's talking about what keeps a satellite in orbit. How the scientist or astronomer that's keeping the satellites and probes that are surrounding the Earth surface, and this is satellites to helping internet and other communications. That's due to the circular motion. Satellites, which are objects that orbit around the other object in the space and follow a covered path around the Earth. And actually the satellite is following objects that keeps missing the ground, while it falls around the Earth, around the on it, so that's moving around the Earth and don't fall down in the Earth surface. And that's why that's due to the circular motion, and that's what we're talking about in the next point. You can see in this video about the motion of some satellites around the Earth in the same orbits. You can see in the same orbit, and that's due to the circular motion. A satellite does not need fall. It continues to move ahead due to inertia. Do you remember inertia in Newton's first law of motion? That any object that stay in his state with any force that's affecting him. At the same time, gravity that's changing the satellite's direction to moving like a circle. And you can see here the moving of the many kinds of satellites around the Earth, so helping for communications and internet and GPS. Different kinds of satellites. So all of this movements that's due to the inertia for Newton's first law of motion and the circular motion. Next step to understanding the circular motion, we should know what's the meaning of circular motion. You can watch here in this videos how the circular motion happen. You can keep thinking about how this is movements or circular motion happen. Many manufactured satellites orbit Earth in almost circular path. Result that an object traveling in a circle like this is accelerating because it's constantly change direction. So, if an object acceleration or in an object force that can affecting to object to move in a circular path, that's called a centrifugal force, and that's word meaning center seeking, and that's force that's moving boys toward the center of the circle and object it moving in it and making the object move in the circle. When the object cutting the force, net force here in the center, that moving in the this is direction or the direction of the ending of the circle. Again, the central or central force that meaning or making the object move in the circle, and the center of this is circle that's the center of force, net force here called centrifugal force. Now you can watch this video that describing the centrifugal force and how the circular motion happens.
Imagine you've got a tennis ball attached to a piece of string, and you start swinging it in circles. Whoa now, watch out for your buddy. Let's take a closer look at the fascinating physics of this simple action. You've probably heard of Newton's second law of motion as it relates to objects moving in a straight line. Turns out, Newton's second law also tells us about the net force on an object as it moves in a circle. When an object moves in a circle, its velocity changes direction. Since the velocity is changing, that means we have an acceleration. And we know from Newton's second law that if we have an acceleration, we have a net force. Now back to our spinning ball. For objects undergoing circular motion, the net force on the object is called the centripetal force. It's a weird sounding word, but it's Latin for the phrase center seeking. It's named centripetal because the centripetal force always points to the center of the circle. The ball has a tangential velocity, so if you suddenly cut the string, it would fly off in whatever the tangential direction was at the moment you made the cut. But assuming you don't cut the string and you keep swinging the ball's tangential velocity is constantly changing directions. This means the ball is accelerating, and the reason it's accelerating is due to the centripetal force. The centripetal force acting on the ball is constantly directing the ball towards the center of the circle, your hand. This, combined with the ball's velocity, keeps the ball swinging in a circle. The same centripetal force that keeps the tennis ball swinging in a circle also keeps roller coasters on the track as they go through a loop-de-loop. So the next time you're having a blast on a roller coaster, you can thank the centripetal force.
Okay, thank you. I hope you understand the free fall and the circular motion by the centrifugal force. And this is the end of this chapter and this is lesson. Any question you can send me, study all. Thank you for listening and goodbye.